Hi, good morning, you guys. I woke up and checked IXL this morning and noticed that there's quite a few of you struggling with finishing up A2, so I thought I'd make an additional video and I would jump ahead just a little bit. Excuse me. Hi. Look a little tired this morning. So I'm going to just jump ahead to maybe, say, 20. I don't know where you guys were getting stuck. Oh, that's way too far. Back up to 28. Okay, so I'm just going to work a few to see if that helps, and I'm going to use cross products, which I didn't use to solve these yesterday, to see if that helps you guys, okay? So it says an elementary school in Campbell gets its school supplies from the district office 4 kilometers away. How far apart are the elementary school and the district office on a map with a scale of 1 centimeter to 1 kilometer? Okay, so we've got this scale of 1 centimeter to 1 kilometer, and if you will always write it with the units attached to it somehow, it will make the problem easier. So set up a proportion where you have it equal to a fraction, where something in the fraction, of course, is unknown. Okay, so it says an elementary school in Campbell gets its school supplies from the district office 4 kilometers away. So if kilometers are in the bottom of the fraction on this side, then kilometers are in the bottom of the fraction on this side. So I put 4 kilometers here. And this maybe is an easy one, but I just wanted you to see this. So this is what I'm solving for. Okay, how many centimeters is 4 kilometers if 1 centimeter is 1 kilometer? So this is, again, this one's a little more straightforward, but so what I can do here is this butterfly method. So cross products, and this becomes 1 times 4, which is 4, is equal to 1 times x, which is x. And then this one is super straightforward, right? No extra solving, just x. So I would just say 4 centimeters. Okay, let's do that again. Bella drew a scale drawing of a city. She used the scale 21 inches to 10 yards. So as soon as I'm given a scale, I'm just going to go ahead and write that down. I hope you're taking notes through this so that each problem doesn't feel like a brand new problem. So 21 inches over 10 yards. And the actual width of the neighborhood is 70 yards. So you see yards are in my denominator. So when I set this up, I'm going to put yards in the denominator. Just like that. Okay. And it wants to know how many inches are in the drawing, right? So all I have to do is solve for inches using cross products. So I would say, okay, what's 21 times 70? And I'm going to be lazy, pull up my phone. So 21 times 70 is 1,470 is equal to 10 times x. And I think you've done this at this point in chemistry, but what would happen with my units here is I would have inch yards, which doesn't make any sense, but then I would come back and divide by yards, and my yards would go away and I'd be left with inches, okay? Divide by 10, divide by 10, and that goes, I'm left with 147 inches. You just set these proportions up. Yesterday in the video I talked about if you're going to go from here to here, that's times 7. So to go from here to here, that would be times 7. Okay, but you can always do it like this. I wish this eraser came in a bigger size. Skip ahead. Okay, Josh measured a community college and made a scale drawing. A building at the college is 102 millimeters wide in the drawing. So 102 millimeters in the drawing. The actual building is 50 meters. So this is actual building is 50 meters. What scale did he use? So 102 millimeters to 51 meters. And we're wanting to get down to, I'm sorry, it's early. We're wanting to get down to 2 millimeters. Okay, so I'm just going to reduce this, and it turns out that 102 is divisible by 51. Like if you were to take your calculator and divide 102 divided by 51, you actually get 2. So this problem works out nice because you're going to get 2 millimeters. And remember, there's always an understood 1. So this would be 2 millimeters over 1 meter. So for every 2 millimeters in the drawing, you'd have 1 meter in real life. Okay, so right here, it's 2 to 1. So this continues on, the same kind of thread, right? I'll do one more like this, and then I'm gonna jump ahead. There we go. So on a public transportation map, 2 stations are 4 centimeters apart. So we're on a map 4 centimeters apart. The scale of the map is 1 centimeter to 2 kilometers. So here's the scale. 1 centimeter to 2 kilometers. In real life, what is the distance between the stations? If on the map they're 4 centimeters apart, so centimeters in the top, centimeters will go on the top. We're solving for kilometers. If we're solving for kilometers, that means my x is going to go on the bottom. Okay, so the x right here. And I can use cross products to solve this. So 1 times x is just x. And this might be worth a quick show really quick so you can see what I was talking about. So I just did 1 centimeter, and you don't want to write this every time, guys. You don't. I'm just showing you what happens with the units. 1 centimeter times x is equal to 2 kilometers times 4 centimeters. 2 kilometers times 4 centimeters. Right? And so when you divide by 1 centimeter, which generally we don't divide by 1, but I'm showing you kind of what happens with the units, okay, then you can see you got centimeters on top and bottom, and they divide out because anything divided by itself is 1. So 2 times 4 is 8, divided by 1 is still just 8. So this would be 8 kilometers. Okay, so again, these problems, they just kind of continue on in the same vein. If found a faster way to erase. This is a new program for me. So I'm going to jump ahead to the 80 mark. And that's where this happens. And this was in the other video, but I'll work a few more just in case you were confused still. So it says, Dan drew a scale drawing of a neighborhood park. The scale of the drawing was for every 6 millimeters, it's equal to 3 meters. Okay. And it wants to know what scale factor is being used. So what you're going to do is you're going to find the one that's the measurement that's bigger, which in this case is meters, and you're going to rewrite the meters into the smaller unit, right? So let's say I don't know what milli means, okay? So I'm just going to pop over here. How many millimeters are in a meter? And milli means 1,000. That's always the case. So what I'm going to do is, let me jump back over here to IXL. I'm going to take this guy right here, and I'm going to multiply him times 1,000. Right? So we just found out that for every 1 meter, there's 1,000 millimeters. So that means for 3 meters, there's 3,000 millimeters. Whoa. I'm not so great at writing with this yet. So I can't put, sorry, that's millimeters. I can't put 6 to 3,000 into IXL though, because it expects you to reduce it. So you need to reduce 6 over 3,000. So kind of the question is 3,000 divisible by 6? Like, can I divide it all the way down? So I'm just going to type in 3,000 divided by 6, and I get 500. So I can actually divide the top and the bottom of this fraction by 6. Ooh, this looks crazy. 6 divided by 6 is 1. And the millimeters go, right? Millimeter divided by millimeter, because we're talking about a factor now, not a measurement. So 6 divided by 6 is 1. And we just found out that 3,000 divided by 6 is 500. So that means the scale factor for this problem is 1 to 500. Okay. I'll do another one of those with you, and then I'll probably stop this because nobody wants to watch a video this long of Miss Young in the morning doing math. Okay. And you can see all my messy blankets on my couch. Okay, so Tanner made a scale drawing of a house and its lot. He used a scale 9 inches to 6 feet. What's the scale factor? So I've got 9 inches, and I have to stay in this order. I can't change the order or it'll be wrong, okay? So I have 9 inches to 6 feet, and I want to decide on the unit of measurement that's bigger. So I'm going to be changing feet because that's the bigger measurement, which means inches is going to stay put, and I'm going to end up with inches over inches, yeah? Okay, so we have 9 inches. And then surely we know this one, that there are 12 inches in a foot. There are 12 inches in 1 foot. Then in 6 feet, I just need to multiply this times 12 to get it to inches. Right? And then 6 times 12, because it's early in the morning and I don't want to mess anything up, is 72 inches. And again, I want to reduce the fraction before I type it in. Okay? So 72 is divisible by 9. So 72. divided by 9 is 8. So I'm going to divide the top and the bottom of the fraction by 9 to reduce the fraction. That's a crazy looking 9. It's a goat 9 or something. And so, and again, inches go away because we're talking about a factor, not a measurement. 9 divided by 9 is 1. 72 divided by 9 is 8. So my scale factor in this case is 1, 2, 8. Okay, guys, I hope those additional examples helped you. If not, go ahead and email me. You guys have been pretty good about that. jana.young@eastemschools.org. Also, I went live yesterday afternoon on Zoom for a little bit, so I'll do that again this afternoon. So just kind of look on It's Learning, keep up after lunch to see when I'm going to be on. Okay, good luck.